Hi you guys, welcome to lesson 2 on the Progressive Sistas platform, and we're going to be going over how blockchain works and the different types of cryptocurrencies. Now this lesson is going to be a deeper dive from our first lesson, lesson 1, so if you haven't watched that already, go ahead and click that link before watching this video so that everything makes sense to you. Alrighty y'all, with all that said, let's go ahead and hop into the first paragraph. Part 1, how blockchain works. Centralized finance versus blockchain. In traditional finance, all transactions are controlled by central authorities such as banks or stock exchanges. For example, when you send money to a friend, the bank updates its own database to reduce your balance and increase your friend's balance. You must trust the bank to keep accurate records. The problem with this system is that it is vulnerable to errors, fraud, or restrictions. If the bank system goes down, you cannot access your funds. If a bank or government freezes your account, you are helpless. Blockchain solves this problem by replacing the central authority with a decentralized system. Instead of one institution keeping the record is shared across thousands of computers worldwide. Everyone has the same copy, so no single person or institution can cheat the system. Cryptocurrencies are digital, which means they will always be found and available on the blockchain. On the other hand, US dollar is both physical and digital, but it will not be found on the blockchain because it is controlled by the bank. So that means it is controlled by a central authority. That's not how it is with cryptocurrency. We have a decentralized system, which means there is no center point of failure or control when it comes to cryptocurrency. Now, this is amazing because it puts you in full control of your money instead of having it in the hands of someone that you don't even know. We are literally giving our money to strangers when we're putting our money in the bank, to absolute strangers. Would you just go give a stranger your wallet walking down the street and be like, hey, hold this? Don't spend none of my money. No, you're not going to do that because it's absurd when we really truly sit down and think about it. So that's why cryptocurrency is just a wonderful alternative to the traditional finance. And I'm going to tell you something that a lot of people do not know, but it's plastered on every single bank that you go into. And it is also inside of your bank account, your bank statements. And that is that the FDIC only insures your money up to $250,000 if the economy is doing okay. So that means if the bank shuts down, it goes bankrupt, whatever happens in this world to where the money and financial systems are just crazy, your money is only guaranteed to $250,000. Now that might sound a lot to someone who doesn't have $250,000, but to someone who has $1 million, that sounds very scary. Knowing that the $1 million that you have in the bank, that you are trusting in the bank, will only be guaranteed, if the economy is doing okay, up to $250,000. What happens to the rest of the $750,000 that person worked so hard for and put in the bank? It's just gone. It's just gone. And you can't say that they didn't tell you this. You just didn't take the time to read it. It is literally on every bank register that you go to, just in these little bitty fine print, but it's there. Now, it may seem like I'm talking very negative about centralized traditional finance, but I'm really not. I'm just giving you guys the truth. Now, the other side of the truth is that centralized finance also offers a lot of security, because when there's anything fraudulent going on with your account, they will file a case for you on your behalf. They will look into it on your behalf, and they will compensate you if they feel that you were done wrong, without you really having to do anything but calling them and telling them, hey, there's some fraudulent transactions that I don't notice on my account. That is the really amazing thing about being in a centralized finance type of environment. Now, blockchain does not offer that. If anything fraudulent goes on with your crypto or your ledger, or somebody hacks into your crypto wallet, there's nothing that anyone can do to be able to get those funds back. There's not a thing that anyone can do to be able to get any funds back that you get taken by scammers, by hackers, by fraudulent activities, or just by you losing anything. But the other side of that is that in order for you to have your own responsibility over your own money, you truly have to take responsibility over your own money. You can't rely on the bank or somebody to come and save the day when you're asking for complete responsibility and sovereignty with your money that you would get with cryptocurrencies. So cryptocurrency comes with complete control over your money, but less security. Traditional finance comes with more security over your money, but less ownership. So now that you have a pretty good understanding of centralized finance versus decentralized finance, let's go ahead and go to our second topic in this lesson. Blockchain as a distributed ledger. A blockchain is essentially a digital ledger like a financial record book that is copied and stored on thousands of computers. Every transaction that happens is broadcast to all these computers, and only after the majority agrees that it is valid does the transaction get added to the ledger. This makes blockchain. Decentralized, no single owner or controller. Transparent, anyone can check the record of transactions. Secure, tampering is extremely difficult because thousands of copies must match. Example, imagine you keep your expense record in a notebook. Now imagine that every person in your city has the same notebook, and whenever you buy something, everyone updates their notebook. If someone tries to cheat by writing a false entry, their version will not match the rest and it will be ignored. As we discussed in our first lesson, blockchain requires a lot of computers on the network to keep the blockchain up and running and accurate. Now, those computers have specific software, according to whichever cryptocurrency they're working with, that are called nodes. So those computers are just nodes, just computers with a specific crypto software onto it to where they can be able to add transactions to the blockchain, okay, and validate the blockchain. Now, these nodes exist all over the world, okay? All over the world. So every copy of the transactions that are placed on blockchain, every node on the network has a copy of it. They have an original copy of it. From the first person who ever joined the blockchain to the last person who ever joined the blockchain blockchain ledger is going to be completely the same for both parties. Now, this is amazing because it creates a lot of transparency and just really makes it so difficult and almost impossible to create anything fraudulent on the blockchain. You would have to have every single node on the network, or a majority of the nodes on the network, first communicate with all of them, and then all of them validate the same transaction and add it to blockchain. That would be really, really, really hard, you guys. And another thing is, you can't go back in history and change anything on a blockchain, because if you do, it will literally not add up. Because these blocks, they contain these transaction data, and it's chained by the previous block information, their previous block transaction data. So if you change one little thing of this block, it's automatically going to change this block, because this block's information, the first one, also correlates with the second block. The second block needs this information to be able to create another block on the blockchain. So you really cannot get around this. Now, there are a lot of different blockchains, okay? But when the word blockchain is mentioned, a lot of people always think that blockchain is just like all the transactions are on just this one ledger. And no. Cryptocurrencies, a lot of them have their own separate blockchains. Like Bitcoin has its own blockchain that works with POW. Ethereum has their own blockchain, but it works with POS. XRP has its own blockchain. And it's just like so many different cryptocurrencies has its own blockchain or its own decentralized ledger, distributed ledger. And that's what makes it really amazing, because it's no matter how these cryptocurrencies decide they want to work, at the end of the day, they are all going to be on blockchain, no matter what consensus mechanism they choose. Now, when we're talking about the phrase distributed ledger, that essentially means that the ledger or the blockchain can be distributed to anybody around the world on any of these nodes. Any of these computers with this software that are operating on the blockchain will have a copy of this ledger. So that's why it's considered distributed. Now, when it comes to banks, nobody's gonna have a copy of that ledger except for the bank and maybe the government. You know, like nobody is gonna be able to have a copy of that because they don't have it to where everything is transparent and just like everything. So like anybody can make a change on that ledger and go back in time and change things on that ledger with a bank and create fraudulent transactions. And of course, let's be for real. If you had access to your own ledger, wouldn't you add a few dollars to your account? Wipe away a few transactions? Deposit some funds in there that's really not there. Like, being for real, no matter how honest you are, it would happen. Now, cryptocurrency knows that people aren't honest, so they're not going to allow you to even be able to do that. But they're still going to give you the ability to have full control over your money, but they're not going to give you the ability to change what's in your account. Now let's go over the third concept, which is going to be blocks and transactions. A transaction is a record of money being sent or received. For example, Satoshi sends 1 Bitcoin to Joe. Transactions are grouped together into a block. Once a block is full, it is linked to a previous block, forming a chain of blocks, hence the blockchain. Example, think of your monthly bank statement as a block. Each page records your transactions for that month. When you stack these pages together over the years, you get a long record of all your financial activity. That's exactly what a blockchain is, a chain of transaction blocks. So, as I was mentioning earlier, every single block on the blockchain is representing a single transaction. Now, that transaction is included in the block. That block has a lot of metadata inside of it, and it also has like the recipient's address, the sender's address, just how many coins they have, the timestamps. It has just a lot of information, but also what information is included is the previous block's hash. Now, a hash is essentially where they take the transaction details, they put it into a system, they funnel it into a system called a hash function, and that system basically jumbles it all up and creates what you would call like a little link. Okay, so basically it's just like made of numbers and letters, like alphanumeric hash, to where it cannot be deciphered, but when it is on blockchain, the computers are reading it, and with that hash, they can read all of the information for that transaction and the previous transactions before it. Now, each transaction receives its own unique hash, its own unique digitalized fingerprint. If even just one detail, one letter, one number, or a period is missing from what you input into the hash function, it's going to give you a completely different, unique hash. So each transaction, even if it's for the same amount, you're sending it to the same person and all of these things, the timestamps themselves will be different, and that will itself create a different hash. No matter if it's just by 1 second difference, it's going to create a completely different hash, which is what helps to keep the blockchain secure. So essentially, blockchain is just a record of transactions being transparent for everyone to be able to see and view and to validate and create a consensus within the blockchain. Now let's go over the fourth concept, which is going to be miners and validators. To keep the blockchain secure and updated, transactions need to be verified. This is done by either miners or validators, depending on the system. Proof of work, POW, used by Bitcoin. Here, miners compete to solve complex puzzles using powerful computers. The winner adds the block to the chain and earns a reward in Bitcoin. This process requires a lot of electricity, but it is very secure. Proof of stake, POS, used by Ethereum. Here, validators are chosen randomly based on the coins they have staked or locked up. They verify transactions and are rewarded for doing so. This process is more energy efficient. Analogy. In proof of work, miners are like students racing to solve a very hard math problem, and only the winner gets the prize. In proof of stake, validators are like teachers selected from a group of trusted teachers to sign off on records. So, because I didn't want you guys to be completely confused in this lesson, I did go over proof of work and proof of stake, POS, inside of the first lesson, but we will retouch on it again here in this lesson. Now, with POW, they're going to be solving this cytographic problem or this puzzle to be able to add the transaction to the blockchain. Now, all these transactions for POW are inserted inside of this pool of transactions. And this is what they call a mem pool. A mem pool is essentially just transactions that have not been confirmed and added on the blockchain yet, because it needs miners to be able to solve that puzzle or that cytographic problem to be able to add it onto the blockchain. This is where those miners are going to be pulling the transactions from. They're going to be pulling it from the mem or the memory pool. But essentially what you need to know about this mining is that these miners, which are people who have these computers with the software on it, and we're going to use Bitcoin for example, it's people with this specific Bitcoin software embedded into their computer, and they have the specific drive and hardware to be able to do these transactions. And what they're going to do is they're going to pull transactions from the memory pool, and they are going to race against each other, against all the thousands other of nodes who have the same copy of this memory pool, and they're going to be racing to try to solve this transaction and place it on the blockchain so that they can be rewarded in Bitcoin and transaction fees. Now, just because one person solves this cytographic problem or this puzzle doesn't mean that they just automatically get rewarded. No, they're going to have to send it out to the rest of the nodes on the network, send out the solution to the rest of the nodes on the network. The nodes on the network are going to validate it by putting in the same piece to the puzzle inside of their computers, and if it works for that transaction, then they're going to have to validate that transaction, and that's when it will be added to the blockchain. So just because one person gets it right doesn't mean that it's just completely right, that it's just left to one person doing all the work. No, it does have to be validated by majority of the nodes on the network. Now, when it comes to proof of staking, you have validators, and these people literally validate transactions. They're not going to be racing against each other trying to solve these transactions. The network is actually going to choose the validator itself randomly based on how many cryptocurrencies you have staked, and that is who is going to be able to validate the transaction and add it on the blockchain. Now, the rest of the validators do have to come to a consensus and have to also agree on this. Now, if they do anything faulty, the cryptocurrency that they have locked up and staked will be slashed. It will be burned, and the network you will never be able to see that cryptocurrency again. So that is why you stake your cryptocurrency, so that you can be more honest and trustworthy and secure the blockchain. Because if you do anything bad on the blockchain, they're going to slash it. They're going to get rid of it. All that collateral that you had backing you is going to be gone, and you will never see it again. Okay? It's just like we can compare this to like your mortgage, right? So you take out a loan and you have your house as collateral, right? So if you don't pay back that loan, they're going to come take your house, and it's not going to be stealing, it's not going to be theft, it's not going to be any of that, because you actually agreed to that. You agreed to be trustworthy and pay back that loan, and you put your house as collateral, like, oh, if I don't pay back this loan, then the house is yours. But I'm going to pay back the loan, so you won't ever get the house, is what a lot of people think. But if you do something faulty, it's all written down. They're going to come for that house, just like they're going to come for your cryptocurrency. Now let's go over why blockchain is considered secure. Blockchain is secure because of three main reasons. 1, decentralization. Thousands of computers hold the records, so there is no single point of failure. 2, immutability. Once data is added, it cannot be changed or deleted. 3, consensus. The majority must agree before a transaction is accepted. Example, trying to hack the blockchain would be like attempting to break into thousands of banks around the world at the same exact time. The cost and difficulty would make it nearly impossible. So once again, blockchain is going to be just a really big distributed ledger to where all the blocks represent transactions, and they are linked together by the previous transactions. And these are going to be available on all the nodes or all the computers that have the specific software on the network. Now, nothing can ever be changed, nothing can ever be tampered with, because if it is, it will not reflect correctly on the rest of the nodes on the network, or the rest of the computers on the network, so then it will be disposed of and it will be ignored, okay? So it has to be agreed on within a consensus. That means proof of work, POS, we also have POH, we have other ways of validating things, but those are the main ones are going to be POW and POS, and it has to be a consensus of the nodes on the network saying that, oh, this is actually okay, we're going to place it on it. And it's not just one or a couple of nodes, majority rules. Majority always rules for the most part, but especially in cryptocurrency and adding things to the blockchain, majority actually rules. Alright, you guys, so I didn't want to buckle your heads with too much information, so I did split this lesson into 2 parts. So now you can go ahead and proceed to the second part of this lesson, which is going to be going over the different types of cryptocurrencies.